Hi, good morning, dear students. Today I will start another chapter, that is triangle. Triangle. Okay. So when we heard the word triangle, then we directly remember three sides, or a figure which is having three sides. In that we have right angle triangle, obtuse angle triangle, and acute angle triangle. So here acute angle triangle means a triangle which the angle, one of the angle is acute angle, or all the angles are equals to acute angle. Okay, if in a triangle, if all the angles are equals to acute, that means less than 90 degree and greater than 0 degree, then we are calling that triangle as acute angle triangle. Then next one is equilateral triangle. So next, based on the angles, next one is right angle triangle. Okay, what is meant by right angle triangle? The angle is how much in a right angle triangle? That is equals to 90 degree. If in a triangle, if the angle is, one of the angle is equals to 90 degree, then we are calling that triangle as right angle triangle. So then next one is obtuse angle. Obtuse angle triangle. So what is meant by obtuse angle triangle? If the angle in a triangle is greater than 90 degree and less than 180 degree, or if in a triangle, if the angle is obtuse angle, then we are calling that triangle as obtuse angle triangle. Okay, these are the three classification based on the angles. First one is acute angle triangle, the next one is right angle triangle, the next one is obtuse angle triangle. Then when we come to the sides, the triangle is divided into again three types. One is equilateral triangle, and next one is isosceles triangle, and next one is scalene triangle. So what is meant by equilateral triangle? So what is meant by equilateral triangle? For example, if I draw a triangle, okay, I will call the sides end points as A, B and C. Then if I consider BC length as 5 centimeter, then what is the length of AB and AC in an equilateral triangle? Let me fast. So here I considered a triangle ABC. In that, side BC is equals to 5 centimeter. AB and AC is unknown here, and I am telling you that the triangle ABC is an equilateral triangle. Then the side length of AB and AC equals to, let me fast, here BC equals to 5 centimeter. Now AB equals to how much, and AC equals to how much? Comment me fast. Ayman gave 5 centimeter as the answer. Hiremat 5 centimeter. Akash, Shaish, Ahmad, so give 5 centimeter as the answer. Yes, that is the answer. That is the correct answer. 5 centimeter. This also 5 centimeter, because it is an equilateral triangle. So in an equilateral triangle, all the side lengths are equals to each other. In an equilateral triangle, all the side lengths are equal. Okay, so that is the first category. In that second one, I'll consider triangle. First I will consider triangle. In that I will mark the endpoints as ABC again. Now I'll tell the side BC is equals to again 5 centimeter, and AB equals to 4 centimeter. Now comment me AC equals to how much? So here I wrote AB equals to 4 centimeter, then BC equals to 5 centimeter. Now AC equals to how much? Okay, I am telling you that ABC is in the second case, ABC is an isosceles triangle. ABC is an isosceles triangle. So Mutaira gave 4, Hiremat, Ranjita 4, then Bhumika 4 centimeter, Prakash, Ayman 4 centimeter. Any other answers? Why only 4? Why not 5? Sagar, Saish, Farooq, Akash, Vishal, all are giving the answer as 4. And I told you that ABC is an isosceles triangle. So what is meant by isosceles triangle? Isosceles triangle means in a triangle, if any two sides are equal, so I can consider AB equals to AC. So in that case, AC value becomes 4 centimeter. Or I can consider BC equals to AC. In that case, it is AC equals to 5 centimeter. Okay, so if I consider AB equals to AC, I am taking BC as a different side. Okay, so that's why it becomes 4 centimeter, because in an isosceles triangle any two sides are equal to each other. So in the first case it becomes 4 centimeter. In the second case I will consider BC equals to AC. So here also two sides are equal. So then I will consider AC as 5 centimeter. So that is also possible. Okay, not only 4 is the answer, we can consider 5 also. Then third one, so I will consider one triangle. This is 5 centimeter, this is 6 centimeter, and what may be the value of AB? So here AB equals to unknown here, and AC equals to 6 centimeter, and BC equals to 5 centimeter, and I am telling you that ABC is an scalene triangle. ABC is an scalene triangle. If ABC is an scalene triangle, then what may be the value of AB? Comment your answer fast. 4 centimeter, 7 centimeter. Any other answers? Six centimeter, 3 centimeter, 5 centimeter. Okay, that's based on the construction, because so this is unknown. Okay, we can consider any length. So that depends upon the construction, because scalene triangle means in a triangle the side lengths are not equal. The side lengths are not equal. So that's why one is 5 centimeter, another is 6 centimeter, another maybe 3 or 4 or 5, not 5. Apart from 5 and 6, it may be any other number. So therefore, so based on the angles, the triangle is divided into 3 parts. One is acute angle triangle. That means the angle is all the angles are less than 90 degree. And next one is right angle. In a triangle, if one angle is equal to 90 degree, then the triangle is considered as right angle triangle. And in obtuse angle triangle, if any one angle is equals to obtuse, that means greater than 90 and less than 180 degree, then we are calling that triangle as obtuse angle triangle. That is based on the angles. And when we consider the triangles based on the side, then again it has 3 categories. First one is equilateral triangle. If in a triangle all the side lengths are equals to each other, then that is equilateral triangle. Then second one is, it is a isosceles triangle. In a triangle, if any two sides, okay, any two sides are equals to each other, then that triangle is considered as isosceles triangle. And the third one is, if in a triangle all side lengths are different, then we are calling that triangle as scalene triangle. Okay, then next comes about congruent figure and similar figure. Okay, next comes congruence, congruent or similar, congruent or similar. Okay, congruent means, so in the previous classes or in the standard 8th and the 7th, we solved the problem based on the triangle. So that means we are considering any two triangles, and in that we are taking the side lengths or angles are equals to each other. Then based on that we are writing a word, triangle dash is congruent to triangle dash. Okay, in the circle chapter, after completion in the second theorem, we considered a triangle. Okay, so this circle, this is a tangent from an external point, we consider that as P, this as Q, this as R, and the center as O. Then we joined the radius and we marked one point, so we mark the center as O. Then in that case we consider the upper triangle and lower triangle, and we consider two sides and one angle, and by using RHS theorem we proved that two triangles are congruent to each other. That means the side lengths and angles all are equals to each other in the two triangles. If for example, if I consider two triangles, if this is equals to 5 centimeter, this is 4 centimeter, and this is 3 centimeter, I will consider this the end points as ABC. And in another triangle I will consider DEF. If this is equals to 5 centimeter, this length is equals to 4 centimeter, this length is equals to 3 centimeter. Then if all the angles are equals to each other, then we are calling these two triangles as congruent triangles. Then we are considering these two triangles as congruent triangles. In a congruent triangle, all the sides and all the angles are equals to each other. So that's why after proving the triangles are congruent, we are considering CP-CT rule, that is corresponding parts of congruent triangles are also equals to each other. Yes, that is CP-CT rule, corresponding parts of congruent triangle. So now here also the side lengths and angles are equals to each other. So that's why we are considering these two triangles, the triangle ABC and triangle DEF are congruent to each other. Okay, or we can change the direction. I will consider the same triangle, that is DEF, and EF is 3 centimeter. I will consider this as 3 centimeter, and DE is 5 centimeter, and DF is 4 centimeter. And see here, angle E 1 line, F 2 lines, and D 3 lines. So here first triangle, second, and I will consider third. First two are congruent because here all the angles and all the sides are equals to each other. Similarly, if I consider first and third one, these two are also congruent to each other because here also side lengths and angles are same. So this is about congruent triangle. Now when we come to similar triangle, for example, I will draw one triangle. So I will consider the endpoints as ABC. So this length is 3 centimeter, this length is 4 centimeter, and BC equals to 5 centimeter. Okay, I consider one scalar triangle. Now I will consider another triangle. I will mark the endpoints as D, E, and F. If I consider this as 6 centimeter, this as 8 centimeter, and this as 10 centimeter. You see here, AB is 3 centimeter, D is 6 centimeter, BC is 5 centimeter, and EF is 10 centimeter, AC is 4 centimeter, TF is 8 centimeter. So what you understood from this? So AB is half of D, correct? AB is half of D, or AB length is half of the DE length. Similarly, AC length is half of DF length. Similarly, BC length is half of EF length. Okay, so that means here the side ratios are same. The side lengths are not equal, but the side ratios are same. So this is half of this length, but the side lengths are not equal to each other. Then in that case, we are considering that triangles has similar triangles. Okay, if the shape must be equal and the sides are in the certain ratios, then we are calling that kind of figures as similar figures. Okay, how many of you understood this about similar and congruent figures? Comment your name first. So in congruent figures, all the shape, side length, angles are equal to each other, and in similar figure the size is in the ratio, certain ratio it is present, and the angles are equals to each other. Okay, that is comes under the similar figures. Okay, simple concept. The next one, I'll give you another example for congruent figure and similar figure. Okay, that is based on the circles. By considering the circle, I am explaining you what is the difference between congruent figure and similar figure. So I'll write, consider a circle with circle with 5 centimeter as radius. Circles, okay, circles with 5 centimeter as radius. So I will draw roughly, okay, one circle and another circle. So this length is how much? 5 centimeter, and this length is again 5 centimeter. So two circles with same radius, two circles with same radius, then these figures are congruent or similar. Just comment your answer. Just comment your answer. I drawn two circles with radius 5 centimeter. Now these two circles are congruent or these two circles are similar. Comment your answer fast. Sagar gave congruent as the answer, Farooq both. Then any other answers? Congruent. Comment your answer fast. So here two circles of same radius, that is 5 centimeter, and next one, here I will consider one circle, or I will consider here one circle with radius 6 centimeter and another circle with radius 4 centimeter. Now in the second case, okay, in the second case the circles are congruent or similar. Comment your answer first. So in the first case some gave the answer as congruent and some student gave the answer as both, and similarly now consider the second two figures. Second case, the first circle is having 6 centimeter as the radius and second circle is having 4 centimeter as radius. Now these two circles are belong to dash, congruent or similar or both. These are the three options in front of you: similar or congruent, similar and both. Okay, so here the first circle is having 6 centimeter and second circle is having 4 centimeter. But here we have to remember one thing is both the figures are circles only, but their radius is different. So therefore these circles comes under similar figures. Okay, these are similar figures. And first one is the case 1. So the figures are congruent. Okay, first case the two circles are congruent because the two circles are having 5 centimeter as radius. In the second case, first circle is having 6 centimeter as radius and second circle is having 4 centimeter as radius. Therefore I consider this under similar figure. But here we have to note one thing is if the circles are congruent, then or if the figures are congruent, then the figures are similar too. Okay, if the circles or if the figures are congruent, then the figures are similar too. That's why we can consider another option, that is both, because all the congruent figures are similar. All the congruent figures are similar figures. But when we come to similar figure, all the similar figures are need not be congruent, because here these are the two 5 centimeter. When we overlap one circle on the other, then the center coincides. Therefore we are considering that as congruent, and similar because the ratios of the radius are in the same. But when we come to second case, so the ratios are same, but when we took one circle and we put that on the other circle, the centers are coincide, but the sides are not coincide, or the circumference of one circle is not overlaps on the other. So that's why we are calling the second case as similar. How many of you understood this? Just comment your name and click on the like button. Comment your answer fast. Okay, next. Comment your answers fast. Then I will go to another one, that is exercise 1. Exercise 1, that is first exercise. In the first exercise we have fill in the blanks. Similarly we have to give examples, and we have one problem in that we have to solve. Okay, how many of you understood this? Just comment your name first. Next I will move to the exercise directly, that is exercise 1. So this exercise completely based on what is meant by congruent figures, what is meant by similar figures, and how to draw or how to show the difference between similar and congruent figures. Okay, the first exercise, exercise 2.1 in our textbook, that is present in page number 30, mathematics part 1. So first main, fill in the blanks. Okay, first main, fill in the blanks. Fill in the blanks. In the first one, all circles are dash. So comment your answer. First option is congruent, second option is similar. Which is the correct answer? All circles are dash. So first thing is all circles are congruent. Second one, all circles are similar. So which one is correct? Comment your answers. Comment your answers fast. All circles are congruent or similar. Here all circles are given, that means plenty number of circles are present, but the radius is not given. Okay, if we consider the plenty number of circles with same radius, then we can call all circles as congruent. But in this case, they consider plenty number of circles, but they not give the radius. So that's why all circles are similar. We don't know the radius, okay, or we don't know the perimeter of the circles. Then second one, all squares are dash. All squares. Okay, in squares all the side lengths are equal and all the angles are equal to 90 degree. All squares are dash. Comment your answer. First one is here similar, second one is congruent. First one is similar, second one is congruent. So comment your answers fast. So all are giving the answer as similar. A different answer. Sagar gave congruent. Ubaid gave congruent. Okay, see here all square circles, just like the circles, the square lengths, if I consider 5 centimeter as one side, then all the other three sides are equals to 5 centimeter, and I can consider 10 centimeter as one side, then all the other three sides are equals to 10 centimeter. That means the sides are in the ratio, but they are not equals. Okay, therefore all the squares are also similar. Okay, then third blank. All dash triangles are similar. All dash triangles are similar. So first option is isosceles triangle, and next one is equilateral triangle. Okay, all dash triangles are similar. Fast. Comment your answer fast. So if you know the first two answers correctly, then you can answer the third one. All dash triangles are similar. Fast. Equilateral. Okay, answer is equilateral. The next one, fourth one, two polygons of same number of sides are similar if their corresponding angles are dash and their corresponding sides are dash. So fourth one, two polygons of the same number of sides, same number of sides in that option A, the first sub question, corresponding angles are dash. Then the second one, their corresponding sides. Sub question, second sub question, corresponding sides are dash. So now comment me only for the first one. So in the first one, they ask their corresponding angles. Two polygons are given of the same number of sides. Okay, polygons means the figure which is having many sides. But here the polygons which are having same number of sides are given. Then sides are similar if their corresponding angle. That means the two figures are similar. If two figures are similar, then their corresponding angles are dash, equal or proportional. Equal or proportional. Okay, if two figures are congruent, then all angles are equal as well as all the sides are equal. But when we come to similar figures, if two figures are said to be similar, then the corresponding angles are equal. Corresponding angles are equal. Then what about the corresponding sides? Whether they are equal or they are in a proportion. So proportion means we can consider ratio in other words. So therefore corresponding sides are equal or proportional. So comment your answer first. Comment your answer first. Corresponding sides of the similar figures are proportional. Okay, proportional. Okay, this is about first main. The next one, second main. Give two different example of pair of. Okay, give example. Give examples. Okay, second main, we have to give examples. In that first one is similar figures. First one is similar figures. So now we have to give two examples for similar figures. Which are the examples? Just give any two examples for similar figures. Give any two examples for similar figures. Comment your answers fast. Give two examples for similar figures. So in the first main you learned about similar and congruent figures. Now give two examples for similar figures. Comment your answer fast. Examples are equilateral triangles you can consider, or you can consider rectangles because all the angles are equal to 90 degree in rectangles, and the sides are having, we can consider different lengths. And when we come to equilateral triangle, in equilateral triangle all angles are equal to 60 degree. We can consider any length of sides, but the angles are equal to 60 degree in equilateral triangle. So therefore according to the definition of similar figures, the angles are equal to each other but the sides are in the ratio. Therefore we can consider equilateral triangle and rectangle triangles are the as the examples for similar figures. Or you can consider squares also, or circles you can consider for the examples as similar figures. Then second one, in that give examples for non-similar figures. Non-similar figures. Give any examples. give two examples for non-similar figures. Comment your answers fast. Examples for non-similar figures. Non-similar figures means the angles are not equal to each other and sides are also not equal to each other or anyone. Okay, but the angles are not equal to each other. That point you have to remember. Circles of radius 3 cm and 6 cm. So they comes under similar figures. Syed Ibrahim. Rectangle, so that comes in the similar figures. You can consider a triangle and a circle. Triangle and circle, the angles are not equal and the sides are not equal, so therefore you can consider triangle and circle. And the next one, you can consider give any example for the non-similar figures. You can consider square and triangle, or you can consider square and circle, or you can consider equilateral triangle and scalene triangle. So that is also example for non-similar figure. Or you can consider acute angle triangle and obtuse angle triangle. That is also example for non-similar figures. Okay, how many of you understood this up to second main? Comment your name first. Comment your name first, then I will move to the next question. Then the next one, state whether the following quadrilaterals are similar or not. State whether the following quadrilaterals are similar or not. I will draw the diagram, third main. So the sides vertex are S and P. So this is 1.5 centimeter, this is 1.5 centimeter, and RQ is again 1.5 centimeter and PQ is again 1.5 centimeter. Then one square is given. And the endpoints are A, B, C, D. Here AB is equals to 3 centimeter, BC is equals to 3 centimeter, CD is equals to 3 centimeter, and AD is equals to 3 centimeter. Okay, in the first figure all the side lengths are equals to 1.5 centimeter. In the second figure all the sides lengths are equals to 3 centimeter. Now we have to tell whether these two figures are similar or not. Similar or not. Comment your answer first. Comment your answers first. Comment me these two figures are similar or not. First, not. If possible, give the reason. If possible, give the reasons. Comment the reason. If yes, then also give the reason. First, Akash Agadi, what is the reason for telling the two figures are not similar? Because corresponding angles are not equal. Said Ibrahim. Angles. Any other reasons? Okay, so when we come to the sides, see here, if I consider dA divided by SP, dA divided by SP, that is equals to AB divided by PQ, AB divided by PQ, that is equals to BC divided by RQ, that is equals to CD divided by SR, and all that are equals to 3 centimeter divided by 1.5 centimeter. 1.5 on the 1.5 2 the, all they are equals to 2 centimeter. But here angles are not equal. Angles are not equal because here when you consider square, the angles are equals to 90 degree, but here the angles are not equals to 90 degree. So therefore these two figures are not similar. Okay, therefore these two figures are not similar figures. How many of you understood this? Sides are not equal, but sides are in the same ratio. Okay. How many of you understood this? Just comment your name. So this chapter is very important chapter. Don't miss the class. So equilateral figure or congruent figure means all the angles and sides are equal to each other, and a similar figure means all the sides are in the same ratio and all the angles are equal to each other. Okay, thank you everyone. I'll continue in the next class.